In this lecture, we will learn how to deal with two-dimensional arrays. We already dealt with one-dimensional array of primitive data types, one-dimensional array of strings, and one-dimensional array of more complex objects, such as the inventory item. So if you remember, we had the inventory item here. We said we are going to create an object of this, or an array of objects of 5 elements, and we are going to call it inventory. So what that does is that it goes to the stack memory, creates inventory, which is a location that has an address pointing to an array of other reference variables, right? So that's a reference variable pointing to an array of reference variables. Each one is indexed by a number following the name of the original reference variable. And now, as you populate step by step here using for loop, looping over the elements one by one, 0, 1, 2, 3, 4, by going from 0 all the way to inventory.length minus 1. What you do is that you go and create new inventory item in it, and this means one by one it's going to be pointing to a new object in the memory that has a description of empty strings and units of 0, because we are creating inventory items without any arguments. So that's how to create an array of objects, a one-dimensional array of objects. What we want to learn today is how to deal with two-dimensional arrays of primitive data types or objects or anything that we want to use in Java. If you think about it, two-dimensional array would look like this. It's a grid, right? It has number of rows and it has number of columns. And for each of these, you will need to index it somehow. But before we go to how to index this, let's think of this as in two-dimensional array as an array of arrays. So if you think about this as, here is a first array, one-dimensional, that we are familiar with. It goes 0, 1, 2, 3. And then another array that goes from 0, 1, 2, 3. All right, 0, 1, 2, 3. And so on. And then if you think about this as an abstract element in a vertical array like this, which goes 0, 1, 2. So this means you can think of two-dimensional array as an array of arrays. And this concept, or the way of thinking about arrays, is going to be very helpful for us to understand certain concepts we will cover later on. All right. Now, what we want to do next is to learn how to actually create that array of two-dimensional array in Java. Now, why would we create two-dimensional array? Why are they useful? One thing to think about is if you're going to deal with any, let's say, board games, you're going to build a board game, all right, it would look like this. Certain positions here that players are accessing, and as they do certain actions, they would move from here to here, from here to here, here to here, or whatever policy or rules that you have for the game. It's going to move the user from one point to another. So a board can be thought of as a two-dimensional array. Another more practical application that we have, you can think of pictures, right? Photos as two-dimensional array. It's two-dimensional array of pixels, and each pixel will be indexed. Each pixel has its own, let's say, degree of color, and then with varying these colors, you can take or you can create a complete new picture using this grid, right? And any picture is basically two-dimensional array of pixels. So that's why we need to use this. Now, how can we create a two-dimensional array in Java? So similar to the one-dimensional array, instead of having a single square or single pair of square brackets, what you will need to do is to list two pairs of square brackets. So that tells Java this is two-dimensional. All right. So here I'm saying I have a two-dimensional array of doubles. It's called scores or reference by scores, and it's equal to new double, and it's going to have 3 and 4. Now 3 always refers to the number of rows, 4 refers to the number of columns. So when I do something like this, what is happening is that, or if we want to visualize this in the memory, could think of it this way. So stack, I have scores as an address pointing to two-dimensional array, right? Here the rows go 0, 1, 2, 0, 1, 2, 3, and that's basically an array of doubles, so each one of them will be initialized to 0, and so on. So that's how you visualize this. So here, this is the number of rows which you list first, right? We said scores of 3 and 4. So this 3 number of rows always comes here. So here, this is the first thing, always the rows, and this is the columns. All right, now columns will go 0, 1, 2, 3 for the 4 here that we have. All right, so defining these two, that just simply creates a two-dimensional array of the dimensions 3 and 4 in the memory. Now, when you think about accessing the elements, right, in one dimension it was easy. We had indexing goes 0, 1, 2, 3, right? This is x, so x dot length will give you 4, and x dot length minus 1 will give you the 3, which goes from 0 to 3. Now, when you think about two-dimensional array, right? So if you have two-dimensional array, things will be a little bit different. You have 0, 1, 2, this is for rows. You have columns, and this is 0, 1, 2, 3. So now, if you want to index this element, you cannot just simply go and say 2, because 2 can mix this, can include this, or that. All right, and you cannot say 1, because here, this is 1, 1, 1, 1, right? So what you want to do is to actually intersect these two dimensions. So you would say it's in row 1 and column 2, right? So that will tell you the element 1, 2 is the element that is in row 1, column 2, so that would be this. All right, so again, when you think about it, this is the array in the memory. Each one of these elements is going to be indexed with the number of rows followed by the number of columns. So it's 0, 0, 0, 1, 0, 2, 0, 3. Since the number of row comes first, you will find all the elements in this row start with 0. All the elements here start with 1. All the elements here start with 2. And the opposite here, the second element will be 0 for all of these, 1 for all of these, 2, 3. Now, each of these elements will have the name of the reference variable, scores, and scores with the sub-indices of 0, 0, 0, 1, and so on. So this is how you access a single element in a two-dimensional array, all right? As opposed to having something like this, x is equal 0, 1, 2, 3, and you could say x of 0, right? Or x of 3. Here you have to have two of these. So it would be scores and the two indices to give you the exact location of the grid or the array you're talking about, array element you're talking about. All right, so to do this practically, what you would do is that you will say, okay, I would like to update a single element in the array. So I go to scores of 2 and 1. So that tells me row 2, column 1. 0, 1, 2, 0, 1. That would be this location here. And then I set it equal to 95. So this goes and updates this one to be 95. All right, so this is how you access a single element in the two-dimensional array, and you could go and just change the value and set it to something new. All right. Now, does it have to be hard-coded like this? No, you could make something that is iterative. It goes over each of these elements and ask or prompt the user to populate it, right? Now, how do you access all of these elements in a systematic way? All right. Now again, I'm going to remind you of one-dimensional array, and then we take that logic and try to expand it to do to the two-dimensional arrays. All right. So here, when we had a single array, single dimension, 0, 1, 2, 3, 4, I could have any values there. Let's say it's referenced by x. And then we said if we want to loop over this, or to access all of these elements, we want to loop over these elements, right? So we would say something like this: for int I is equal to 0, I is less than x dot length, I plus plus. And what we will do is that we will say x of I is equal to, let's say, for example, let's say we had already an array or a scanner that was defined earlier, kb dot next int, for example, something like this. All right, so it prompts the user, takes the input, and go and assigns it to the ith element of the array, and this ith element is going to move from 0 all the way to x minus 1, the length of x minus 1. Now, let's expand this logic to two-dimensional array. All right, 0, 1, 2, 0, 1, 2, 3. So if we think about it in terms of array of arrays, so the first row here can be accessed in the same exact way that we just talked about single or one-dimensional array. So 4, all right, I'm going to call it int c is equal to 0, c is less than 4, c plus plus. All right, and then I would say, for example, that is called scores. All right, this is what I want to access. Now, but if I access c, what does that mean to me? Anything. All right, so notice here I used c because we are looping 0, 1, 2, 3. That seems to be the columns, so I'm going to call here an index called c. Right? Now, the problem is, if I say scores of c, that's not sufficient, because all of these elements, they have the c of 2. Right? This is the same column. So this means I would like to specify that I am in row 1 or row 0, then I am in row 1, then I'm in row 2. All right. Now, to access all of these elements in order, then I need another loop that loops over these elements. So here, for int row is equal to 0, row is less than 3, row plus plus. And here I can add the row. So this means I'm accessing the row scores at the row and column. Now let's trace this. This goes from 0 to 3, this goes from 0 to 4. All right. So how does that work in terms of tracing these nested loops? All right. So here we have R. And here we have C. Let's take something not as thick as this one here. So R is equal to 0. That's the first part of the loop. R is equal to 0. Then 0 is less than 3, yes. Then go and execute everything inside this loop, which is this part. So if I go and execute inside this loop, I go and set C to 0. C 0 is less than 4, yes. Execute whatever inside, do that thing. Then go back, increment C by 1. C becomes 1. Execute, yes, because 1 is less than 4. 2, 3 is less than 4. 4 is not less than 4. Stop. So that exits this inner loop. Then go back and increments R by 1. So R becomes 1. Again, 1 is less than 3. So go ahead and do all the contents of that loop, which is going to do the same thing, 0, 1, 2, 3, 4, with all of these executed except for the fourth. And then r becomes 2. And the same 0, 1, 2, 3, 4, 3, 4. Then r becomes 3, which not less than 3, so we stop. So that's how you trace something like this. So notice here that we successfully accessed all the elements. When r is equal to 0, here, we accessed columns 0, 1, 2, 3. Then r increments becomes 1. Then we scan 0, 1, 2, 3. Then r becomes 2, 0, 1, 2, 3. So this way you can access the elements of an array in a systematic way, all of it, right? So this means to access all the elements of a two-dimensional array, we need nested loops, all right? One for the rows, as you can see here, and one is for the columns, all right? So one for the rows, one for the columns, and then you can do whatever you want, whether you are accessing or whether you are assigning values, that's completely up to you. All right, so let's, this means if I want to access again certain elements, I could go again for loop for the row, for loop for the column, and then I go and access row, column one by one, and that's by using the reference variable and then the two indices, and then I could just go and print that, right? That's the opposite of assigning the values. Now I'm reading the values. One last thing I will just talk about before we go to BlueJ and start to see some examples is that you could hard code values in two-dimension array just like we did in the one-dimension array. What you will need to do is that you will have curly braces, and then inside this, for each row, you will have new curly braces for it separated by commas. All right, so that tells you for the outer curly braces, each group of this is an element separated by a comma, and inside each of these elements, it's another set that is separated by comma 1, 2, 3. So that is going to create the 1, 2, 3, 4, 5, 6, 7, 8, 9 array. All right. So that tells me I have 3 columns, and each I have 3 rows, and in each row I have 3 columns. So that's 3 by 3, 9 elements. All right. So that's how you initialize or hard code values to a two-dimensional array. So this is exactly what's happening here. 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be assigned this way. All right. So let's go and check an example before we continue with new concepts here. This is a two-dimensional array. I'm going to create it with a scanner to prompt the user. I have 3 elements, rows, 4 columns, and then I'm prompting the user for inputs to assign it to this array. So here I can go, it will prompt me, I'm expecting it to prompt me for 3 times 4, 12 elements in this case. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it stops, all right? Now if I try and go and print the contents of this array and try to just print line scores like any other objects, it's just going to print type or the class and the location. Here it's telling me 2 square brackets, which tells me two-dimensional array of type double, and it has this location. So that's not very useful. So what I want to do is to go and prompt or print to the user the values. So here I'm going to do something like this. Again, another nested loops I would need it to print element by element. And then there's a number of rows, number of columns, and then I go and print scores row column with a space after it. So if I do this, and before we do that, let's actually, instead of prompting the user, let's go and hard code the values just to save some time here. So I'm going to set scores to is equal to curly braces, and here curly braces 3 rows we said, and 4 columns, right? So 3 rows, and each one has 1, 2, 3, 4, 5, 6, 7, oops, 5, 6, 7, 8, and then 9, 10, 11, 12. All right, so this is assigning the array scores. Let's do it this way. Scores. All right. I am doing. I'm missing an equal here. There we go. All right. So here, and then we print. Now the problem is it's going to print. It's looping over two-dimension array. Yes. Row 0 has 0, 0, 1, 2, 3, 4. 0, 1, 2, 3, which is 1, 2, 3, 4, and then row 2 or row 1, row 2, and then we are printing all of these. The only problem is that we are printing this in that way, so it's listing all the elements, but it's not listing it in the more intuitive two-dimensional form that we would imagine. To do this, that's your responsibility, which is to create an empty space or a new line after each row. So here I'm reading rows in this for loop. After I read all the columns of a single row, I would like to move to a new line to create a new row. So that's why I put the system.out.println line here outside this for loop. So compile, and now it will look much nicer. Now it doesn't look good because of the spacing. Some of the elements are taking 2 spaces. So one better way is you could do something like this: printf, and take this here and just say this is going to be a, let's say, 0.1 total plus space, and that is just printing this element here. So compile. Oh, I didn't put the specifier. Yeah. There we go. Let's move this to 4. There we go. Much better. All right. So each element is going to take 4. I didn't count the decimal point. So I said 3. It's still messing the format. 4 is better. Even 5 would make it better spacing. Here, there we go. So it looks much nicer. So that's how you print that array, right? So as we said, this is if you just place scores in print line statement. It's not very useful. This is how you need to print a two-dimensional array. If you're going to print the two-dimensional array multiple times in the same code, it doesn't make sense to have this as a redundant code. It would make sense to have a separate method that goes and performs this functionality for you. All right, so the next thing we want to learn is how to find the dimensions of a two-dimensional array. All right, so how to find the dimensions of two-dimensional array. If you remember again, in a single or a one-dimensional array, the length field, so this is x is pointing to this, x dot length would return, dot length without this, right, would, x dot length would return 0, 1, 2, 3, so that would be equal to 3. 4, right? 4 elements from 0 to 3. Now, what if you say two-dimensional array dot length, like scores dot length? What would it return? Now, since we are thinking of two-dimensional array as an array of arrays, what will happen is that when you set, all right. So when you set the two-dimensional array dot length, what will happen is that length field is going to return the number of rows. All right. Again, remember, two-dimensional array is an array of arrays, right? So it's going to tell you how many rows are there. Now, for each one of these rows, the length field will give you the number of columns. All right, does that make sense? So for example here, if I go and say something like this, the array has this number of rows, and I just say scores.length, it's going to tell me that this array has 3 rows. All right. Now, what if I want to know number of columns? All right. That is not the business of the whole scores.length. Scores.length only gives you number of rows. Now, if you want to find the number of columns, you will need to go to one of these rows, which is scores of 0. All right. Notice here that scores of 0 means all of this row. This is scores of 1, scores of 2. That's why we say a 2-dimension array is actually an array of arrays. So that scores of 0 tells you this is the first element in the 2-dimension array, which is this row. Then dot length would tell you that in this row we have 4 columns. All right, so here I would run this, and then that would give me 4 columns. All right, so this is how you access or know the dimensions of your array in Java, or 2-dimension array in Java. All right, the next couple of things that we want to do are the basic operations on 2-dimension arrays. All right, what if you want to add all the elements in this array? So again, running total, you would go and create an empty variable, let's say total, which is set to 0. I'm going to save some space here and just say that equal to 0, right? And I have this array defined this way. And then what I want to do is, let me just first comment all the previous demos. There we go. All right. So we have hard-coded values 1, 2, 3, which is basically the same array, and then here total is equal to 0. And then what I will do is that I will go and iterate over the elements one by one, and every time I read a new element, I just add it to that running total, to that accumulator, right? So here, every time I read a single element, I will add and then store it in total. All right. So here, that would add all of these elements. Then I will need to print that value. So that would tell me the total is 78, right? So that is how to add the elements in a 2-dimension array. Now that's simple. Adding all the elements, just scan over all the elements and add them one by one. That's simple. The other thing that can be a little bit tricky is how do we add the elements in the row? All right, so what I want to do is to add these numbers alone, these together, these together. So this means you need to operate on small parts of that 2-dimension array, right? So in this case, something like this would work. So one thing you need to think about is that if you want to add to them the rows of an array, this means that you have to deal or to think of it in that way. So here I have an array. I have 3 rows, 4 columns each. So in this case, I would like to add these elements together, these together, and these together. So this means I will result in 3 values, right? That is the sum of row 0, row 1, row 2. So now instead of creating a single element, like total here, single accumulator, what you want to do is to create an array of accumulators, right? So in this case, you want to create an array of accumulators to store the values in each of these rows. All right, so here we have a single accumulator, which is going to be overwritten every time, right? So here I'm just going to define or declare this one. It's complaining because we did not come. So int total, right? So here I have a single accumulator. I go row 0 all the way up to the numbers.length. Numbers.length is going to give me the number of rows in an array. So from row 0 to numbers of dot length, I'm going to initialize my total, right? Then I'm going to add the columns from 0 to the number of row dot length. So this means the number of columns in the row of numbers. All right, so the first row, so for example, row 0 has 4 elements. So that would be 4. Then row 1, numbers of 1 dot length is going to give me the number of columns in the second row, and so on, which is going to be 4 for us in this case because all of them are set to 4 columns. Then what I do is that I accumulate these values in total, print that, and then go back for the next row. I initialize 0 total again to 0. So that's the key. If you have a single accumulator, you will need to go back and set it to 0 every time you go over that rows. So like this, 1 plus 2 plus 3 plus 4 is 10, 5 plus 6 plus 7 plus 8 is 26, 42. All right, if you do not do this, if you do not accumulate here, this is going to give you an error. You need to be very careful with this. All right, it will accumulate. So this means the last one is going to be actually the total of all the elements in this two-dimensional array. Because you move to the next row, so after rows equal to 0, you add the first 4 elements, which is amount to 10. Then you go back, increment row, you go to the second row, and then add this to the old value of total, which is 10, and so on. So that's not accurate. What you want to do is to initialize total again inside the loop every time you go over a row. Another solution to solve this problem is you could define this to be an array of accumulators. So new int of 3, all right, this is equal to, and then what you want to do here is that you will say for this number of rows I will have a counter for int j is equal to 0, for example, and then I will say every time I go over the number of rows, or I could use the number of row as a counter, and then what I will do is that I will say total of row is equal to the accumulation here, and then I will print of row. So that is going to work. All right, so that's another option to do this. Now the opposite, what about columns? If you want to do this with columns, then you will need to change the logic of your loop, right? Let's say here that we have int total, again a single accumulator that we are going to override. So here you want to loop over columns, right? So in this case, you need to find the number of columns, and the number of columns is going to be with the first element of the rows, right? The first row dot length is going to give you the number of columns, and that is going to set the number of columns for everyone. So it's 4 in this case. Then you initialize your total is equal to 0, and then what you do is that you loop over the rows. All right. So loop row 0, row 1, then row 2. Add these, store it in total, print it, and then move to the next column. All right. Now notice here that column is the outer loop, but it's the second still. It has to be the second element in the numbers. All right. So this means that when column is equal to 0, rows go 0, 1, 2 with the column 0. Then column increments to 1, 0, 1, 2 with column 1, and so on. All right, so this is going to give you something like this, 4 values this time. 1 plus 5 plus 9, that's 15. 2 plus 6 plus 10, that's 18. 3 plus 7 plus 11, that's 21. And then 4 plus 8 plus 12, that is 24. So now you added columns. So that's a little bit tricky, but you have to be very careful about what you're using to find the length and how you set your loops to loop over rows or columns as you decide to do. All right, so again, number of rows would be the field here, dot length, that gives you the number of rows. If you say numbers of sub 0, for example, dot length, that is going to give you the number of columns. Now, does it have to be 4 for everyone? All right, so these are the examples of summing row, column. These are all the examples we saw. All right, but one important thing that we need to cover is, does it have to be the same number of columns for each of the elements? And the answer is no. You could define an array that has, for example, 4 rows, but each row has its own number of columns. All right, again, that emphasizes the concept of thinking about arrays as, or two-dimensional arrays as arrays of arrays. All right, this means that every array or every element in the two-dimensional array has its own number of columns. All right, if you have something like this means that you have like inconsistent array. So for example, here given this, we have 4 rows. That's what we are seeing here, 4 rows, right? But for the first row, it has 3 elements. The second row, it has 4 elements. The third has 5 elements, right? So here, 3, 4, 5, and then 6. All right, so that's why we say, if you remember here in this example, the demo I showed you, when I tried to find the number of rows by saying scores of 0 dot length, in this example here, you will notice that I said assuming that all rows have the same width, which is not necessary. It's not mandatory there. All right, so you could define a ragged array that has different number of rows. So something like this. All right, notice here that you specify the number of rows, but you do not specify the number of columns, and that's fine. Java is going to accept it. And then for ragged, I'm going to define each row to be an integer of 3, 4, 5, 6, completely up to you. All right, that should work, no problem. So that's how you define, access, add, assign, deal with everything you need to do with two-dimensional array. Right. The last thing before we close is how to pass it as an argument for a method. All right, and that is here is not something that is different from single dimension array. So here is an example. We have two-dimension array, 4 weeks, 7 days for each week. Then I'm going to randomly populate this with a temperature in a reasonable range, all right, using a random generator. Then I'm going to print the temperatures in these 4 weeks, 7 days per week. So that would look like something like this. Here we go. So this is day 1, day up to day 7, week 1 to week 4, and each day has its own temperature, right? Generated randomly and printed using this. Then what you want to do, for example, let's say I would like to convert this into, so that's in Fahrenheit, and I would like to convert this into Celsius. So I go and create a method, F to C, which takes an integer as an input of two-dimensional array, and it returns a two-dimensional array of type double. It goes and sets double is equal to C temps that equal to new double F temps dot length and any number of columns. Then what it does is that it loops over the ftemps as an input, and it takes the value, subtract 32, multiply by 5 over 9, and then it's going to assign this to the ctemps as two-dimensional array. After I'm done, I'm going to return the reference variable of, or the address of ctemps, right? And this I could, for example, here, um, say here, for example, f or c temps is equal to f to c of temps. All right, and here that is a double of two-dimensional array. All right, and then I could repeat this by printing again, but this time just with ctemps. Ctemps here. So I'm going to copy this, put it here, here, and oops, there we go. Compile. Temps C to F to C. So, all right. So here we have created random array. Here we are printing this array, and then I'm going to create a double ctemps, which is equal to new double temps.length, and any number of columns, and then here I'm going to call f to c with temps and assign this to ctemps. Then I'm going to print ctemps, which is going to be a double. So here I changed a little bit, have specifier for the floating point, and then in the ctemps or c to f to c, what I did is that I just take the elements of the input. All right, after creating this array that has the number of rows and equivalent number of columns, and then I just convert, assign, and then return that reference variable. So if I run something like this, it's going to give me, this is the table, when sent it to this one as an input, like here, and then I return that as a double two-dimensional array, and then here I'm going to print it, and which gives me something like this. So again, passing arrays to and getting it from methods is exactly the same. Just all you need to do is to specify that it's two-dimensional array, and that's it.